Okay, let's unpack this. We're diving deep today into something pretty fundamental our source material focuses on.
Right. Equations in one variable. Sounds basic, maybe?
Yeah, maybe, but it's foundational. Most people get the idea of an equation, two things being equal.
Mm-hmm.
But our sources, they really zero in on a specific kind.
The linear ones.
Yeah.
And the mission seems to be showing just how, well, powerful these simple-looking things are.
Exactly, and how they crop up in, everyday kinds of problems.
So what makes it linear and in one variable, according to the material we looked at?
It's pretty straightforward, actually. Just one unknown thing you're trying to find.
Like x or usually.
Right, those usual suspects. And crucially, that unknown, that variable, it's only ever to the power of 1.
Ah, okay. So no x squared, no square roots of y, none of that more complex stuff.
None of that. Simple examples the sources give are things like 3x minus 5 equals 0.
Or like 8 minus y equals 15. Clean, simple structure.
One variable, power of 1. And the goal, they really hammered this home, is always to solve it.
Which just means finding that one specific number for the variable.
That makes the statement true, the value that works.
Okay, and here's where it gets really interesting, I think. The sources lay out this core idea for solving them.
The rules of equality.
Exactly. It's all about balance, isn't it? Whatever you do to one side.
You absolutely have to do the same thing to the other side, keep it perfectly balanced.
It's not just, randomly moving numbers. It's this deep principle.
Yeah, like if you have, say, 2x plus 5 equals 11, the sources show you step by step.
First step, get the x term alone.
Right, so subtract 5, but from both sides.
Okay, so that leaves you with 2x equals 6.
Still balanced. Then you use the same rule again.
Divide by 2, in this case.
Both sides, again. And you get x equals 3.
It's systematic. Adding, subtracting, multiplying, dividing, always applied equally to both sides.
And what's really cool is how this simple balancing act isn't just for abstract math homework.
No, the sources make a point of showing how it connects to, well, actual word problems.
Translating a real situation into one of these equations.
Yeah, maybe you're figuring out, I don't know, a price after a discount.
Or travel time, or maybe the dimensions of a room based on its perimeter. Things like that.
You first have to identify what it is you don't know.
That becomes your variable, your x.
Then you build the equation based on the information, the relationships, given in the problem. Because the problem is essentially saying something equals something else.
Right, it's setting up that equality.
And once you have that equation written down,
you just use those balancing rules we talked about. Add the same, subtract the same.
Until you isolate the variable and find its value. It really does simplify things that sound complicated at first.
Turns them into a clear path.
So what's the big takeaway for you, the listener, from this deep dive?
Well, it seems clear from the sources that these linear equations, the one variable kind, they're more than just algebra exercises.
Definitely. They're a core problem-solving tool. A structured way to think about unknowns.
Yeah, a way to represent relationships and then methodically find answers using that fundamental idea of equality.
Turns what's the value into clear, logical steps.
Which brings up kind of a final thought. Think about maybe a small challenge or problem you faced recently. Something where you needed to figure out an unknown quantity based on some facts.
Even if you didn't grab a pencil and paper.
Yeah.
Were you maybe intuitively using the same kind of balancing act?
Trying to keep relationships equal in your head to figure it out. Something to consider.